I'd like to start today's story with nothing but a little red spot. And I want to imagine that this is a red blood cell. We know loads about these things, right? We know they're 7 micrometers wide. They squeeze perfectly down capillaries, for example. And they're very numerous in the bloodstream, having been produced in the bone marrow of things like long bones. Wonderful, great news. But how the heck does this thing get round to every single cell in the body? That's the question we want to answer today. So in order to try and help you with this, I'm going to introduce what you believe is a box with 2 holes in. But actually it isn't. This here, let me see if I can get the right blue. I'm not sure I have. This here, believe it or not, is a right atrium. Okay, now don't worry, just trust me on this. You might be thinking, James, where are we going with this? But just give me a chance. The point I want to make here is that our red blood cell initially is in a blood vessel leading to this right atrium. So my blood vessel is traveling up and into my right atrium of my heart, okay? And it's going to become clear in a second. Now, you might want to reflect on what the right atrium must be doing for this blood vessel to get into it. But it's got there via this vein here, and this vein here is called the Vena Cava. I sometimes call it the Vena Cava. I'm never totally sure exactly how I'm meant to say it, but I'm going to say it like that. All well and good. So our red blood cell, well done, has got into the right atrium of the heart. What happens next? Well, this right atrium begins to contract, and it squeezes our red blood cell down. It squeezes our red blood cell down into here. And here is what we refer to as our right ventricle. Okay, our right ventricle. Now, before we go any further, I want you to be aware that this here has squeezed through a valve. Now, I'm not drawing it particularly well. I'm told I'm not meant to tell you what the name of it is, but hey, come on, I might give it away towards the end of the video. But anyway, this blood has been squeezed down, and what's going to happen now is that our right ventricle, which of course must be relaxing to allow this red blood cell to come in, is going to squeeze, and it's obviously it's going to fill up with a bit of blood down here. But when it squeezes, it's going to squeeze up and out. And this red blood cell is going to get squeezed now back up, and it enters a little passageway which is just behind the right atrium, and it ultimately comes out of a vessel at the top and the back of the heart here. And this blood vessel here, so imagine it's sort of squeezed up and behind the right atrium, not through the right atrium but behind it, and it's now moving up towards the lungs, which of course is right next door to the heart itself. And it gets there via this vessel here. And this vessel, I'm going to put it on the other side here. This vessel here is what we call the pulmonary artery. Now remember, with arteries, they always lead blood away from the heart. So that's fine, that's doing exactly that. But now at the lung, our blood and our red blood cell, which of course is traveling up here to the lung, it passes through the capillary network at the lung, specifically around, goes past one alveolus, and of course what's going to happen now is that we now have oxygenated blood returning, and I'm going to sort of squeeze it down like right here, and I'm going to introduce you to the next part of the story, and that is our left atrium. I've gone a bit too, let me see if I can get rid of those lines a little bit. Let me do it slightly differently. So now we're going to get, with our left atrium appearing, now we're going to get this vessel with the red blood cell coming down like this, now entering what we call our left atrium. Okay, now before we move on, let's make sure we can name this vessel up here. This is our pulmonary vein. Remember, veins, a bit like the Vena Cava, always lead blood back to the heart. So the blood comes into the left atrium while the atrium is relaxing. It then squeezes, and the blood is forced down again through a valve. And where do you think it gets squeezed down into? That's right, it gets squeezed down into our left ventricle. People keep telling me recently that my F's and my T's look exactly the same. So this is a T, and this is a lovely curly F, left ventricle. So my blood is now down here. And again, this left ventricle now squeezes upwards and outwards, and our little blood cell gets fired at the top of the heart, remember, behind the left atrium again, and it's going to come out of an arching blood vessel like this. And I've not done this very well. Let's imagine that it sort of emerges here, and it comes all the way down, as well as up, by the way. We'll come back to that on a different day. So it comes all the way down, and this now oxygenated blood, it delivers oxygen to the body, or let's call it the rest of the body. And then now our deoxygenated, we've come down here, we've got this hemoglobin saturated with oxygen blood. Our red blood cell passes by, let's say, a working muscle, and then of course it's deoxygenated. It passes back into the vena cava this way through a series of smaller veins leading to a major vein, in this case obviously here the vena cava, and this blood makes its way back, right back to where we started. So let's just sort of see if we can see a big picture here. I'm actually going to zoom in a little bit. Let's just zoom in a touch. Let me just zoom in a touch, see if we can get that. Okay, let's look at it now. So we've effectively, guys, if you have a look at this, we've effectively got two loops, okay? So you've got this loop up here, and then you've got this loop up down here, okay? So we have two loops, and it's worth being aware of that. Lots of other animals, including smaller mammals, lots of birds as well, they only have a single loop circulatory system. Ours is a double loop. And guys, I should have said as well, this big artery that's leaving here, this here of course is your, I'll name it up here, is your aorta. It's the biggest artery in the body, leaving the heart, leads to the rest of the body. Just bear in mind as well, the aorta does branch upwards to, for example, the head, right? Well, it breaks into smaller arteries and branches that way. They're called other things. And so just be aware of that. We're looking at the big picture. That's what we describe as heart structure and heart function. A couple of quick reminders: veins, arteries. We've got valves here and here. And the other thing, guys, I should say is we've also got valves here on the entry to the aorta, and here on the entry to the pulmonary artery. And just remember, with valves, guys, they prevent backflow. Okay, so they prevent backflow. It's really important to stress that. So anyway, a slightly ugly yet hopefully, I guess, intuitive understanding of what this heart does. Oh, I will just draw one other thing. Do you notice how this wall is a little bit thicker? Okay, that has been done deliberately, okay, that thicker wall. The left ventricle, if you look at the job it has to do, it has to fire the blood much further. So therefore it has to be more muscular in order to achieve that. And one of the things you'll find is if you train lots and lots, your left ventricle will become stronger, more powerful, and that's why we're representing this with a thicker wall on the left ventricle. I keep saying one last thing, we've got one atrium, we have two atria. Okay, so just look out for that atria at the ending. Ventricle's easy because we've got ventricle for one, and to make it plural, it's ventricles. Okay, so two ventricles, one ventricle, one atrium, two atria. Just be aware of it. Cheers.